All right, so this lesson that we're going to take today correlates to a lesson we've already done. It's going to be on the same pages as what we did, I believe, on Wednesday. Oh, no, it's its own pages. So let's see, page 133. So this is lesson 3. So we're in chapter 2, lesson 3, and we're going to write two-step equations. Oops. You guys don't cut it now. This comes, today's date is 11/6. So I'm going to recreate my circle on here. You're going to do your work on your circle. When we're done, then you're going to cut it out and glue it on. Okay. So your circle has a circle. And then it has sections. So what we're going to do is come up with words that tell us to add, words that tell us to subtract, words that tell us to multiply, and words that tell us to divide. So let's start with adding. So what are some words that tell you you're going to add? Okay, yep, could be add, but let's go beyond that since we already have that as being part of our wheel. Okay, more than. What else? What else tells us to add that isn't the word add? Pardon me? Product is multiplication. We'll save that up for multiplication. What's the answer to an addition problem? Sum. What else? What's the old word that you guys used to use? Begins with a P. Plus. There's a whole lot of words like more than, greater than, taller than, older than. Okay, all of those mean more than. Okay. Anything else you guys can think of? We got to add already. All right. Well, maybe as we think of more words, we can add them. All right, now we're going to talk about words that tell us to subtract. So obviously subtract is already spoken for. So what are some words that tell us to subtract? Less than. What else? Minus. What else? What's the answer to a subtraction problem called? Negative. No, that's not a negative. What's the answer to a division problem or subtraction problem? Difference. Difference. What's the one that you guys used to do when you were little? When you wouldn't say subtract or minus. It's like when you take away. Remember? It was the old one. Everybody used that one. Take away. Like you're in trouble. I'm going to take it away from you. And again, less than has a lot of cousins like fewer than, smaller than, younger than, shorter than. Those are all meaning subtraction problems. There's some other ones. I'll share one, and we can actually put it one for adding and one for subtracting. Decreased. We do see that. There's also this old-fashioned word, diminished. I am seeing it coming back more and more. For addition, the opposite of increase or decreased is increased. Okay, so that can also show up there. All right, let's talk about some words that mean to multiply. So obviously multiply is off the table. We already got that one. What are some words that mean to multiply? Times. That's what we see more often now. What else? Product, the answer to a multiplication problem. Okay. Ooh, I think of something else I want to put on the subtraction one. Okay. This word of, think back to percent proportion you guys were learning last year. What number is 16% of 32? That of told you to multiply the 16% times your mystery number. Let's see. Here's a couple words that mean to multiply by a specific number. Twice. What are you multiplying by? So you multiply by 2. It has another name, double. Means the same thing. And then we also have triple. What does that mean to multiply by? By 3. There's actually, the British use the word thrice. That means to multiply by 3. And then we also do words like quadruple, and so on and so forth. Okay, that's a good start. Let's talk about words that mean division. So divide. Okay. So what are some other words that tell you you're going to divide? Quotient. That's the answer to a division problem. Joshua? Oh, you're going to get the quotient in? Okay. What rational number is really telling us to do division? A fraction, right? So fractions also kind of indicate there's a division problem. And a fraction is the same thing as a ratio. So a ratio also is telling us to do division. Let's see. How about, I got a phrase I want to write down is divided by. Oops, sorry. Divided by. And then there's also divided into. Now there's one more word that I want to add over to subtraction, and that's subtracted from. It's a phrase. Okay. Now this is obviously not exhaustive. There's way more phrases that we could add, but this just gives us kind of a start. And again, as we come across some new ones, we can add it into our chart. But I'm going to star a couple of these. I'm going to star more than. I'm going to star less than. I'm going to star subtracted from. I'm going to star divided into. And there's actually one more that I can add to the addition one. That's added to. And I'm going to put a star next to him. So at this point, what I'm going to ask is that you guys go ahead and stop, go ahead and cut out, and go ahead and glue that circle onto your notes page. So I did want to add one more division word, and that's the word per. Per. Like you're going miles per hour. It's a ratio or rate word, and so when you're comparing with per, P-E-R, then that also is going to give you a division problem. So we're going to add a couple things on the outside. So towards the bottom of that page, we're going, and I need to go to a new page. I want to list out those starred phrases. We had less than. We had more than. We had divided into. We had added to. Let's see, there was subtracted from. Was there any other one I starred? You should have starred as well. And you guys should be using color. That really does help make things stand out. Was there any other one that I had? Why are these unique? Why did I star them? What makes them different than the other phrases? Do you know, Devin?
Because those are commonly used.
They are commonly used, but that's not why I starred them. Now, when we're writing equations, which we're going to review how to do that, your job is to read what is written and translate it. And when I say translate, that means every word, every phrase, gets to be something in our equation. Anything that can't become something in our equation, that's going to become our variable. But we have certain phrases that change how we translate. So think anyone in here who takes Spanish? Okay, a couple people. So when I, in English, am describing a house, I say, oh, that's a really pretty white house over there. In Spanish, you say, oh, that's a really pretty house white. You say La Casa Blanca. So in Spanish, they switched the order of the noun and the descriptor. But in English, when we translate it, we switch it back. Because it makes sense for us as we describe our noun. So we always put our adjective in front of our noun. So these are what we call switcher phrases. And with a switcher phrase, when I read in my equations less than that says what came in front is going to come after subtraction sign. What came after less than gets written in front. So I'm going to switch the order just like we do in Spanish. Instead of saying La Blanca Casa, I say La Casa Blanca. Okay? Now, let's see. If we're going to be writing equations, oh, we also have some other phrases. Let's write these down. Is, or no, let's say, try that again. The sum of the difference of the product of and the quotient of. These phrases also gets translated as an additional part into our equation. When I'm saying 2 times the sum of 5 and x, that 2 is going to get multiplied by everything in that sum. So what that tells me is I need to use parentheses. This is switcher phrases. And then the last one is we need to have words that mean I need to add, let's do an equal sign. So there's the obvious word, equals. But what else might you read in a sentence that says, oh, this is where I write my equal sign? It's pretty simple. Any ideas? 3 is the sum of 5 and what number? According to that sentence, where does the equals go? What word means equals? 3 is the sum of 5 and what number? Okay. What tells me to write equals? You guys make me sad. Is in most mathematical sentences gets translated into equals, or some sort of symbol that tells me this part is going to get compared to this part. Okay. Other words that might be equals are all the to be verbs. Is, are, were, was, will be. All of those to be verbs generally are what we translate into meaning equals. Okay, so are, was, were, will be. That'll probably do us right now. So all of those words tell us to write equals. All right, now's the time to go over to the odd page, and let's do some examples. So this is when I'm going to say, if you haven't done it, pull out some colors, because you're going to want to color code as we go through things. So the first one we'll do, we're going to write down the steps. of, in words, what you should be doing, and then from there on out, we're just going to kind of color code and look for stuff. So, okay. Everybody good? We'll do one more like that, short one, and then we'll do a longer one. 15 equals 3 more than 6 times a number. Oops, sorry. Fifteen equals 3 more than 6 times a number. So what's the word that tells us equal sign? Yeah, that one's kind of easy. Okay, we can identify our numbers. 15, 3, 6. Okay. What operations do you hear? No, tell me the phrases. More than tells us to do what? More than means to add. Okay, what else do you hear? Times, that tells us to multiply. Okay, now, what haven't I underlined at this point? Or boxed or something, a number. So that gives us a hint that that's what our variable is going to be. Now, there was one thing we didn't do. What else does more than tell us? Yeah, if you look back at your list, it's a switcher phrase. So that means the 3 is going to come after the plus, and the 6 times the number is going to come in front of the plus. So that's what we have to watch out for. Okay. So we start by defining our variable. X represents, in this case, a number. And then we start translating. 15 equals, now the 3 is going to go after the more than, so I have plus, and then I put the 3 after it. 6 times the number goes in front, 6x. So I translate 15 equals 3 more than a number, 6 times a number is 15 equals 6x plus 3. I've got 3 more than that 6x, okay? Then I solve it. First thing I do is subtract 3 from both sides. I'm going to use my symmetric property. And so I'm going to take the remainder on the left side with 6x. That's now going to go on the right side. And then the 15 take away 3 is a 12. And then the inverse of multiplying by 6 is dividing by 6. And we get x equals 2. So we can say the number is 2. Okay. So last example, number 3. You buy 3 books. That costs the same amount. And a magazine comma, all for $59 or $55.99. If the magazine costs $1.99, how much does each book cost? So this isn't as streamlined as our other example. Okay? You buy 3 books that cost the same amount and a magazine, all for $55.99. If the magazine costs $1.99, how much does each book cost? So let's start and just think about, in words, what are we buying? Okay, let's be specific. We get 3 books and 1 magazine, and what do we know that they all equal? So if I write it out in words, that's basically, logically, what my equation's going to be. Now what I have to do is go back and find out some information. Okay? What do I know about how much the books cost?
They're all the same cost.
Did they tell me how much it was? Oh, so guess what? When they asked me this question, that tells me that's my x. So x is going to equal the cost of each book. Okay. Did they tell me anything about the magazine? What did they say about that? So that is going to go here. Okay. Now that I have everything I need, I'm going to go ahead and write my equation. I have 3 books. So 3x represents the cost of the 3 books. And 1 magazine, which they told me was $1.99. And all of that was the $55.99. So here's not what I'm going to see when you're translating equations, is you're not going to have x by itself and a whole bunch of math being done on the other side. If you're doing that, you're trying to solve the problem. You're not telling me what it says. Okay? So let's start doing math. First thing we do is deal with the constant. So I'm going to subtract 199 from both sides. That gives me 3x. These guys, again, cancel out. On this side, I have $54. Then I'm going to divide both sides by 3. And I get x equals, well, 3 goes into 5 once with 2 left over and into 24 8 times. So what does x equals 18 mean in this problem?
Each book is $18.
And there's exactly the answer to this problem. Each book costs $18. Okay? All right, that's it.